an instrumental analytical chemist. That means I use instruments to analyze, identify, and detect chemicals. Two instruments that I use in my research are mass spectrometers and vacuum ultraviolet spectrometers. A mass spectrometer, or mass spec, uses weight. It makes a spectrum of the weight of an analyte, of a chemical. And so we can use this to identify the differences between chemicals. Now, the blue chemicals on my slide that are kind of under these scales are the same weight. They just have different rearrangements of atoms. But the green chemicals are different weight. They're the same kind of monomeric species. They're just the same species repeated over and over again. And one of them is longer than the other one. So mass spec is good at telling the difference between the two green molecules, but not so good at telling the difference between the two blue molecules. Vacuum ultraviolet spectroscopy, or VUV, is better at analyzing the differences between two chemicals that are so closely related. And we do this in vacuum ultraviolet spectroscopy by looking at the absorption of light. And we take the absorption, we shine vacuum ultraviolet light, and chemicals absorb that, and we identify what's left over, the absorption profile. And so we can think of that kind of like a shadow. So you can see that the two shadows on the blue chemicals are very different, but the two shadows on the green chemicals are much the same. So the two techniques, mass spec and VUV, are complementary, and that's what my research focuses on. In my research, I've taken these two instruments, the vacuum ultraviolet spectrometer and the mass spectrometers, and I've combined them, both literally by taking the two white boxes that I have in my lab and putting them together and engineering and hooking them up, and also informationally. I take the information from a mass spectrometer, the mass, and I take the vacuum ultraviolet absorptions profile from the vacuum ultraviolet spectrometer, and I put them together. Because each presents a fingerprint. Each of these instruments has a chemical. When a chemical goes through them, they generate a fingerprint of that chemical. And I've taken these fingerprints of the two different kinds of chemicals and I've merged them. So for instance, when I take an injection, when I take 10 chemicals and I put them in the mass spectrometer by itself, 8 out of 10 I'm able to identify correctly. And when I take those same chemicals and I put them through the vacuum ultraviolet spectrometer, I'm also able to identify 8 out of 10. But it's a different 8 out of 10. So by combining the two instruments together, the information from the two instruments together, I'm able to get 10 out of 10 confirmation of chemicals. Not only that, but the chemicals that are identified have less uncertainty about their identification. Their library matching is better. That's how I'm working to improve chemical identification.